The last one is, I would say, a little bit different than others. Okay, so I'm going to start with 33. Oh, title, sorry. Equations, the last one. Equations with rational exponents. Remember last time, maybe I should just take my lesson out just for one more minute. When we got to this, I also said, well, it's also a polynomial. But it's easier to solve it thinking that it's quadratic in form because at its core is this. Fine. But when we looked at radical equations, I also said that a radical equation, not in those words though, but I put it in writing here. This radical, it's the square root, in other words, x to 1/2. This is what I'm getting at right now. Okay, no pink, sorry. This is what I'm getting at right now. The radical is the same with an expression with a fraction as an exponent, also called rational exponent. So there is a little bit of an overlap here, right? So when we talk about rational exponent, we will really be talking about a radical equation, but presented differently. So there is an overlap. So I would write in parentheses for you to remember that when we talk about rational exponents, I'm going to write another type of radical equations. So nothing to be afraid of, but they're somewhat different. Okay? So pretty similar with radicals, but we are not going to use the exact procedure that we used in plain radicals. Okay. So 33 on page 185, x minus 4, everything raised to 3/2 equals 27. Yes, you can change it into a radical if you wanted to. That will be no problem. However, here's what we are going to do. This is the rational exponent. The rational exponent is this piece. The power. It's a ratio. A rational. It's a rational number. It's a ratio. So when we see something like this, first we want to try to eliminate the denominator. Disregard the numerator of this fraction for a moment. If I want to eliminate the denominator, what should I do to both sides? Very similar, same idea that we applied last time at this point. Yeah, we square, right? To eliminate this, which is basically the square root, we raise everything to the second power. So what we have on the left, and I'll tell you what we have on the right, 27 squared. So what do we have on the left?
X squared minus 16.
X minus 4, everything to the third power. Let's discuss this. It's okay. So I have a quantity raised to power 3/2, and I want to raise it to the second power. The rule says that I copy the base, and what do I do with these exponents? Which operation do I perform? Say it again.
Okay, so the two cancel out you.
So we multiply them, right? So 3/2 times 2/1, always simplify before you multiply. So that's how we get the base raised to the third power. Because I multiplied 3/2 by 2/1 and I got 3. So that's how we get this. So we eliminate the denominator by raising both sides to the second power. Okay, perfect. Now what? Of course, I raised 27 to the second power. What do you think we have to apply now to both sides? And what should we do to both sides to, now I want to eliminate this power. How do I eliminate that power?
For ever any reason you try to remove the numerator first?
I need to remove the denominator first and then the numerator. That is the procedure. So let's write note. Always eliminate the denominator first. For these equations, of course. And then we'll reach the numerator. So what should we do here to both sides to eliminate this?
Take the cube root.
Awesome, thank you very much. Apply the cube root to both sides. The cube root only has one answer. Let me refresh your memory for a second. What did we say about the square root of x squared? Well, we're going to review it today also. It's plus or minus x, but not when it comes to an odd root. So the only answer is x minus 4, and the only answer on the other side is, and you can put the cube root on 729. I can show you if you want me to show you how to put the cube root. I don't use the math feature. I prefer. So then x equals 13. I prefer the caret. So what I do in the graphing calculator, I put 729 caret and in parentheses 1/3. 1 divided by 3. And I got 9. Any questions on this problem before we move on? Yes, since we raised both sides to a power, we have to go back and check. So back to the original problem, which was x minus 4 raised to 3/2. That equals 27. So when I plug in 13, 13 minus 4 is 9. And now I have to raise 9 to 3/2. So 9 caret, I always put parentheses, that's me, 3/2. When I hit enter, I have to get 27. If I don't get 27, I have to start from scratch. It means that I made an error, something was wrong. So this is how we deal with equations with rational exponents. Let's choose another. Any questions for me before we move on? Anything?
I don't have a question, but my internet connection is really bad, and so if I cut out or I drop the call, it's not because I did it home.
That's fine. As you know, I had that glitch last week myself. Okay, so let's continue with, let's say, 34. X plus 5, everything to 3/2, equals 8. It has the same power. Let's do it. Since I wrote it, I didn't want the same power. I wanted a different power. Yeah. So then we're going to look at 38 after this one. Since I started it and I wrote it, let's do it. And this is 2/3 equals 4. Okay. So first, what would you recommend we do? First step. We want to eliminate, yes? Square both sides, very good. What do we have on the left? On the right we have 64. What do we have on the left?
X plus 3 cubed.
X plus 5 to the third.
5.
Yep. I know that's what you meant. And next, what do we have to do? It's a friendly operation because it's the cube root. We are not afraid of odd indices. We are afraid of even indices. They're not friendly. So x plus 5 is x plus 5. The cube root of 64 is 4. So then x equals negative 1. And you could say, show me, because you raised to the second power, and I have to show you. So negative 1 plus 5 is 4. And if 4 raised to 3/2 is 8, then I'm in business. If not, I'll say, sorry, I have to start from scratch. So 4, caret, parentheses, 3 divided by 2. The sophisticated calculator don't need parentheses, but I don't know what type of calculator you have, and I don't trust that. I prefer putting my parentheses as they should be. Okay, so I get 8, so I have to accept the solution as being negative 1. Now let's move on to 38. X plus 5 raised to 2/3 equals 4. What is the first step now? And with this, we completed this section. And now we'd like to look at a word problem after we finish this one. Because now we know 8 different types of equations, what's the use? So I want to show you at least one application with all those. And the rest will come in handy later on. Okay, so what do we do next?
You raise both sides to the power of 3.
Excellent. The right-hand side will be 64. Please remember, each equation has only one equal symbol. Do not write to the sides. Left-hand side, equal symbol, right-hand side. Okay, so what do we have on the left-hand side?
Alright, x plus 3 to the second power.
I don't know how my x plus... Yeah, I'm sorry. It's my writing. I'm sorry. Good. And what do we do next? And how many solutions we expect now?
Square both sides.
Excellent. How many solutions do we have to get?
2.
Yes. Take the square root, not square both sides, but take the square root. I should write the absolute value. Instead, what will I write?
Plus or minus.
Thank you very much. So then x equals negative 5 plus or minus 8, and we have to separate them because we can simplify them. So when I separate the first, what will I get?
3.
Very good. And for the second one? So solutions 3 and negative 13. I raised to the third power. Normally it should work, but I still have to go back and check. So x plus 5 to 2/3, does that equal 4 with 3? So 8 to 2/3. 8, caret, parentheses, 2 divided by 3, close the parenthesis. 4, correct. With negative 13. Negative 13 plus 5 is negative 8. In parentheses, negative 8, close the parenthesis, caret, in parentheses, 2/3. Close the parenthesis. If I get 4, I accept both. I got 4, I accept both. So x equals negative 13 and 3. This completes all those 8 different types. You should be very proud of yourselves. Okay, I like to at least show when we apply what. So here's a problem, problem 110 on page 187. And we have p equals negative 1.6, the square root of t plus 62. Models the percentage of jobs. So this percent of jobs. Okay. In the US labor force, P, held by men T years after 1970. T, number of years after 1970. Okay. Use the mathematical model to determine the percentage of jobs in the U.S. labor force held by men in 2010. Round to the nearest tenth of a percent. So they're asking us to find the percentage, find P in 2010. So first we need to identify how much is T for 1970. So can anyone tell us how much is T for 1970? Since T represents number of years after 1970.
0, right?
Yes. Yes, indeed. So it is 0. So T equals 0 for 1970. Therefore, T will be what for 2010?
40.
Great job. All I have to do is find P when T is 40. Negative 1.6, the square root of 40 plus 62. I grab my calculator. I put negative 1.6. When we start with a negative, we have to start with this symbol. 1.6, then second and the square root. This calculator doesn't need parentheses, but I always put parentheses under the square root or any root. Go outside, you don't have to, but some calculators will force you to. So that's why I don't know what type of calculator you have. Oops, oops, oops. Plus 62. And we press enter, and we'll see the percentage. 51.88. They're asking us to round to the nearest tenth of the percent. So it will be 51.9. So I will write P equals P equals 51.8807, and I will approximate, as they said, 51.9%. Second part of the question. According to the formula, when will 49% of the jobs in the U.S. labor force be held by men? So when will 49%? So we are asked when. The percentage will be 49%. What do we have to do?
Set the equation equal to 49.
Excellent. Thank you very much. So 49 equals negative 1.6, the square root of t plus 62. We know 8 types of equations. Which type is this one? Because almost everyone is different. And I have to know the method. What is the method? What type of equation is it from those 8 different types? Anyone?
I don't know.
Say it again.
But I don't know.
Okay.
Would this equation have 2 solutions as a square root?
No. The answer is we don't know. Hold on. If we don't know, we go back. I'm glad my recycling bin is not far. Oh, that's not the page I want. This is the page I want. And I'm going to keep it. Okay. Is it linear?
No.
No. Is it rational?
No.
Is it quadratic?
No.
Is it polynomial?
No, I don't think so.
Is it radical?
I don't think so, no.
But it has a radical.
Does it?
What is this? Is it absolute value?
No.
Is it quadratic in form?
No.
Does it have a rational exponents? You can say yes, in a way, because it does, but we don't see them.
Yeah.
So it must be radical. It has to be one of these. We're going to add to the list later. We're going to add two more exponential and log equations. And these will be it. That's it. We are not going to learn more than 10 different types of equations in this class. But we're going to add these in chapter 4. And that's it.
Really?
So it's a radical equation. Good. We identified it correctly. And now the next question is, how do we solve it?
Combine like terms.
I can only combine which terms?
Subtract 62 and
Very good. Okay, so 49 minus 62, negative 13 equals negative 1.6, the square root of t.
So
So,
is the negative 1.6 and the square root of t like one term, basically?
yes, it's a product, exactly. Oh, absolutely. Great job. Next step. If there is no symbol, it's multiplied. I can't separate those. Okay, next. What would you recommend next? Always keep in mind, simplify and factor. Say it again.
divide by negative 1.6.
Indeed, absolutely. So 13 divided by 1.6, because they are both negative, so 8.125. 8.125. Great job. Final step.
Use square.
Excellent. So t will be, when I square this number that I just got,
66.
66 years after what?
1970.
Excellent job. Great. According to the model. Now, since everything is upside down and totally different, we can certainly say, we don't know if this model still holds. We have to wait and see. So it appears that is 2036. Very good. This was an example of a radical function and how we solved the radical equation and what for and how it was applicable, etc., etc. So we clearly identified from all these 8 equations, types of equations, we identified that this is a radical. It has a radical on a variable. Good. I'm going to keep that moving forward. Okay, I created a little quiz, so let's work on it for a few minutes.